Properties of logarithms. There are properties for expanding and condensing logarithms. Property number 1 says log base b of m times n equals log base b of m plus log base b of n. So if you have the log of two things being multiplied, that can split apart into addition. Or you can go the other way around. You might have two logs being added and you need to condense it back to multiplication. It just kind of depends on the situation. Property number 2 shows us that division expands into subtraction, or the other way around, subtraction can condense back into division. And then property number 3 is actually the most useful property. If you're taking the log of something that has an exponent, the exponent can be moved into the front. So if the instructions are to expand, you'll move the exponent to the front. If your instructions are to condense, then the number in front will move back to being an exponent. These rules also apply to natural log, to ln. So our first example says use the properties of logarithms to expand, and then we want to also evaluate. So we have multiplication here, log base 9 of 9 times x. I can split that into addition, log base 9 of 9 plus log base 9 of x. Then using the properties from the previous section, log base 9 of 9, because those numbers are the same, the whole thing just turns into a 1. So 1 plus log base 9 of x. Log of 10,000 divided by x. So division expands into subtraction. Log of 10,000 minus log of x. And keep in mind, because there's no base, we have an understood 10. So using the properties from the previous section, I can convert 10,000 to 10 to the 4th power so that it cancels out with the log base 10. So because the 10s are the same, all of this part just goes away and I'm just left with the 4 minus log. And you don't have to write the little 10 if it's a 10. 4 minus log x. We have multiplication, that expands into addition. Log of x to the 5th plus log of y to the 6th. Then also we have exponents. And the third property says that exponents can move to the front. So our final expansion would be 5 log x plus 6 log y. This one has a radical, and if you remember from the last section, we don't leave radicals when we're dealing with logarithms. We have to change it to a fractional exponent. So there's an invisible 2 on the outside, invisible 1 on the inside. So that's x to the power of 1/2 is what we want to put on the top. So it's log of x to the 1/2 over y cubed. I have division, which expands into subtraction. Log of x to the 1/2 minus log of y cubed. And then my exponents move out front. 1/2 log x minus 3 log y. All of these properties are useful when we're solving equations where we have to apply logarithms, which we'll do in the next section. This one has a mixture of multiplying and dividing. Everything on the top represents multiplication and will expand into addition. Everything on the bottom represents division and will expand into subtraction. So if it comes from the top, it's going to be positive. If it comes from the bottom, it's going to have a minus in front of it. All right, expanding this out, we'll have log base b of x cubed. It's positive because it came from the top, plus log base b of y squared. Now the things from the bottom will have minus in front. Minus log base b of z to the 5th minus log base b of w to the 7th. And then finally move the exponents out front. And you could do all of this in one step instead of, oops, the 2 goes there, instead of 2 steps. That would be fine. And the 7. And then that one's finished. Now let's go the other way around. Use properties of logarithms to condense. When possible, evaluate without a calculator. So I have addition. Addition condenses to multiplication. 25 times 4 is 100. And let's put in our invisible base 10 to help us see that we can go a little bit farther with that, because 100 is 10 to some power. 100 is 10 squared. And now that I have two 10s here, all of this goes away, and the answer is just 2. Log base 2 of 40 minus log base 2 of 5. Subtraction condenses to division. So I'm dividing 40 by 5, which is 8. And then always check and see if the number you have can be changed to the base to some power. Can 8 be written as 2 to some power? Yes, it can be written as 2 to the 3rd. So the 2's are the same, all of this goes away, and you just have a 3. 5 natural log x plus 2 natural log y. If there are numbers in front, the first thing to do is put them back as exponents if you're condensing. So natural log of x to the 5th plus natural log y squared. And then I have addition, which condenses to multiplication, so I have to multiply natural log of x to the 5th times y squared. Again, we have numbers in front. Those should all go back to being exponents. Log of a to the 6th minus log of b to the 3rd plus log of c to the 7th. We have a mixture of adding and subtracting, so look at the sign in front of each log. If it's positive, then that value will go to the top of the fraction because that's multiplication. If it's negative, it will go to the bottom because that goes with division. So you just want one log, and then a to the 6th is positive in front of that log, so that goes on top. B cubed has a minus out front, so that goes on the bottom. C to the 7th has a plus in front, so that one goes to the top. Now, the button on your calculator is the common logarithm, which is just log base 10. So if you need your calculator to find the value of a log that's not base 10, you have to use the change of base formula, which is the formula log base b of m equals log m over log b. The base, which starts with b, goes on the bottom, which starts with b. So for this example, it says use common logs and a calculator to evaluate to 4 decimal places. So the original problem is just log base 7 of 13. Putting that in the change of base formula, we have log of 17 divided by log of 7. Put that in the calculator, round to 4 places, 1.3181.